One of the common questions I received this week was how to determine formal charge and how to know when to make a double bond in a Lewis structure. And so I'm going to walk through two different examples that hopefully should help with that. And this is related to one of the questions on recitation as well, but it's still good practice. So one of the molecules we saw was sulfate, SO4 2-. So let's draw two different Lewis structures for sulfate. Right, so to start, we're going to write out the valence electrons for sulfur and oxygen. Right, so sulfur is neon 3s2, 3p4 for 6 valence electrons. I have 4 oxygens, and oxygen is helium. They're in the same group, so they have the same number of valence electrons. Helium, 2s2, 2p4. 6 electrons for each oxygen. I've got 4, so there's 24 electrons there. And then don't forget the negative charge. The negative charge, for each negative charge, I'm going to add in 1 more electron. So I've got 32 electrons to assign. I'm going to draw 2 different Lewis structures for that. So I'm going to put sulfur in the middle, the least electronegative element in the middle, and we're going to surround it with oxygens. All right, so the structure on the left, in both of these structures, I have to assign 32 electrons. On the structure on the left, I just wrote 4 bonds, 2 electrons each. I just assigned 8 electrons, so I'm going to have 24 electrons remaining. The structure on the right, I just drew 2 double bonds, so that's 4 bonds there, and then 2 more single bonds, that's 6 total bonds, 2 electrons each. I still have 32 electrons. I've assigned 12 of those electrons. I've got 20 electrons left. So the next step, let's fill the octet of the surrounding atoms. So one on the left, I've got 24 electrons to assign. There's 6. All right, there's 12. There's 18, and here's 24. So I had 24 electrons assigned. I assign all of those 24 electrons, right? I've assigned all those electrons. That's a valid Lewis structure. The one on the right, I've got 20 electrons left. So, okay, I'm going to fill the octet of these 2 oxygens, right? These 2 oxygens now have 6 electrons. And I'm going to fill the octet of the other 2 oxygens. The other 2 oxygens already have 4 electrons because they're in a double bond. They only need 4 more electrons each. So I have 6 plus 6 is 12, plus 4 more is 16, right? And then 4 more down here is 20. So I've assigned all 20 electrons. I've got 0 electrons remaining. So which one of these is the correct Lewis structure? Which one of these is a better Lewis structure? And for that, we have to determine formal charge and assign formal charge. Formal charge, we're going to determine that by taking the group number, right? And we're going to subtract the number of assigned electrons. So we've got group number minus assigned electrons. And for assigned electrons, we count 1 electron for each bond. And we're going to count all lone pair electrons for the atom in question. So sulfur and oxygen are both group 6. So let's see what this looks like. So here's sulfur, which is group 6, 1 electron for each bond. So I've got 1, 2, 3, 4 bonds. That means I've got 4 electrons assigned to that sulfur. So let's see, group 6 minus 4. Okay, that's a +2 charge on this central sulfur. Oxygen is also group 6. Let's take a look at these oxygens. These oxygens, we count all electrons that are lone pair. So 1, 2, 3, 4, 5, and 6. And we count 1 electron per bond. So there are 7 electrons assigned to each of these oxygens. So that's for sulfur. This is for oxygen. Oxygen is group 6, and I've got 7 electrons assigned, so there's a -1 charge on all of these oxygens. So that is a valid Lewis structure. I've assigned all the electrons that I have to assign. I've filled the octet of sulfur, I've filled the octet of oxygen, but is there a better Lewis structure, and what would it be, and how do I know that there's a better Lewis structure? How do I know to make a double bond? Well, if we have a separation of charges, and this is one of the questions in the homework, it asks about a separation of charges. So something like this. I've got a negative charge next to a positive charge. I've got this negative charge next to this positive charge. That means we can share electrons between these two atoms and remove this charge. So when possible, we would prefer to have a Lewis structure that carries as little charge as possible. It has the fewest number of atoms carrying charge. So if I take 2 electrons from here and go and form a double bond, and take 2 electrons from here and go and form a double bond, that gives me this structure here, where now I only have 4 electrons on these 2 oxygens, right? I got 2 lone pairs. I have 2 lone pairs on oxygen. Now let's calculate the formal charge for this sulfur and these oxygens. Well, again, oxygen is group 6, and these oxygens, right, 1, 2, 3, 4, 5, and 6. So 6 minus 6, right, these oxygens are neutral. And these oxygens on the left and the right are going to be -1, because again, 1, 2, 3, 4, 5, 6, 7 electrons assigned to this oxygen, 7 electrons assigned to that oxygen. 6 minus 7 is -1. Our central sulfur, right? 1, 2, 3, 4, 5, and 6. 1 electron for each bond. Our central sulfur is in 6 bonds, so 6 minus 6, a neutral charge on that sulfur as well. So this is the better Lewis structure for us, because I have the fewest number of atoms carrying charge. I have violated the octet rule for sulfur, but that's fine because sulfur has access to d orbitals and can accept more than 8 electrons. But that's how I would know to form a double bond. When I have 2 opposite charges adjacent to each other, I can get rid of this charge by bringing a pair of electrons down to form a double bond, and then bring another pair of electrons down to form another double bond. We could have gone through another structure where I only had 1 double bond in the molecule. I could have gone through a structure like this, where sulfur would only be +1, and each of the oxygens would be -1. Overall, we'd still be -2, right? 2 of these would cancel out, and we could see, okay, I can get rid of that positive charge on the sulfur completely by forming a second bond. So hopefully that helps give you a better idea of how do we know when to make a double bond, right? Follow the rules that we know, assign those formal charges, and if you have 2 formal charges, opposite formal charges that are adjacent to each other, and this atom can violate the octet rule, well, maybe then we can share those electrons to help get rid of some of that charge, reduce some of the charge.